Hello everyone. In 12.6 we are talking about circular and periodic functions. The unit circle is an example of a circular function. Sine, cosine, and tangent are some examples of periodic functions. So when we graph these, you'll kind of see their cycles and their patterns, but we are just focusing on general cyclic and periodic functions so that we can kind of get an idea of what we're talking about. So they talk about how we can find the sine and cosine at particular points. So say I had the point P of root 7 over 4, and then 3/4, and then they're asking us to find the sine and the cosine, or the x and the y value at those points. Well, remember that these are just the x and y values, so the cosine of P is square root of 7 over 4, and the sine of P is 3/4. X value, y value, cosine value, sine value. Just as we saw with our unit circle. Speaking of, if we need to find the exact value of cosine of 690, we are still thinking about our unit circle. You still want to ask yourself, what's your quadrant? Are you positive or negative there in terms of our ASTC? But since 690 is very clearly above 360, let's figure out what our coterminal angle is. So you can subtract 360. When I subtract 360, I'm left with 330. So that is my coterminal angle that I can now do my process of quadrants, positive or negative, reference angle with. So quadrant. 330 lies in the fourth quadrant. It's more than 270, less than 360. Cosine ASTC is positive there, so I know whatever my answer is, it's going to be positive. My reference angle, 330 to get up to 360, my reference angle is 30. And now we do our trig handjive. So I know my answer is positive. For reference angle of 30, we'll put down our ring finger. Cosine's above. I've got 3 fingers above. Palm of 2, square root of 3 over 2 is my answer. In radians, same idea. So I want to think about what's my coterminal, which quadrant am I in, am I positive or negative there. So negative 3 pi over 4, I can add 2 pi. I can also think about if I was going to be graphing this. So if I graph this, it is going to be in my third quadrant. My coterminal angle is 5 pi over 4. So I'm in quadrant 3. In terms of whether I'm positive or negative there, sine is negative since only tangents are positive. So no, whatever my answer is, it is going to be negative. My reference angle, I have an pi over 4. Therefore, I know my reference angle is always going to be 45. 45 is my middle finger with my trig handjive. I've got the square root of 2 below my finger. And palm of 2. My answer is negative. Negative root 2 over 2. So think about what your coterminal angle is. Then talk about your quadrant, positive, negative, and your reference angle, and you're good to go. And it's really not much different than what we were doing in 12.3. And lastly, this section gives us the idea of the periodic function, which has y values that repeat at regular intervals. One complete pattern is called a cycle. So the pattern itself is the cycle, whereas the horizontal length of this cycle is called the period. So the period tells us how long it takes before the cycle starts to repeat again. To identify the period, you pretty much pick a point in your pattern, follow your pattern, and see how long it takes for the whole pattern to repeat. So here I've got some sort of pattern. It's got this like crazy points in it. So I'm going to pick a point where I can easily identify where I'm at. So I'm going to pick this point right here. So in my pattern, I go down, I go up. Once I get to this point, I start to repeat that exact same pattern again. So, therefore, my period for this particular function, I have to go from this pi over 6 point to pi over 2. So overall, my period here is pi over 3. Because pi over 6 plus pi over 3 gets me pi over 2. If it is easier to identify, you could have also started right here. You could have started at 0, traced it up, do the little dip, down, do the little dip, and landed at pi over 3. Same thing, your call where you would like to start. If you would like to start at a more regular part of your cycle, such like a pi over 2 or something, where it's a little bit easier to identify what your period is, you are more than welcome to. Here I've got this little zigzag pattern. So again, I'm going to pick a point where it's going to be easy to identify where I'm going. Here I see I am down at -1. This pattern goes up, goes down, and then just continues to go up and then down. So I start to repeat / I end my cycle at pi, starting at 0, ending at pi. My period is pi. If you started at the pi over 2, so you're starting at the high point, down, then up, that again is pi. So it doesn't matter where you start in your cycle, so long as you go back to a point that looks exactly like the point where you started at, you're able to determine how long that horizontal distance is, aka what the period of your function is. And that's about it. So I'll see you in class.